Good afternoon, everyone. You must have come across with the algorithm subject. In algorithms, we come across with algorithms, as we all know. I'll just give a brief introduction about the algorithms, and then I'll start with a particular method and an example with. So we have come across with algorithms, and algorithms very clearly says that it's a step-by-step procedure to solve a particular problem. Now, when we are going to solve it by step-by-step procedure, obviously we cannot apply one algorithm or one algorithmic technique to all the different kinds of problems. We are having different algorithm techniques to solve different problems. So first we have to understand which are the different techniques that are available to be deployed. So we have first and foremost is the brute force method, which doesn't involve anything called as the technicality over there. Only what is involved over there is it's just an exhaustive search. For example, linear search could be considered as a brute force method wherein you are searching for a particular element throughout the entire array. And then let us go to the next one, the greedy method. As the name indicates, we are trying to find out, or we are trying to get a more and a most better solution. So hence we call it as a greedy method. We are not getting satisfied with something called as only, you got a solution. We want the best solution amongst them. So therefore, there might be a number of solutions available to solve a particular problem. Those are called as optimal, those are called as feasible solution, and one which is the best amongst them is going to be considered as the optimal solution. For example, there are two people who are able to solve a particular problem. The person one, if he solves the problem within half a minute, and the second person who solves the problem within 1/4 of a minute, then in that case, we would consider the person who has solved in a minimal time. So this is what called as a greedy method. The same thing we are going to apply over in some problems like job sequencing with deadlines, which is shown on the screen, which is shared on the screen as well. And then next, we have dynamic programming method as well. We have the next one is the decrease and conquer method, divide and conquer method, which are to name a few of them. But let us just concentrate on what is a greedy method over here. So I'm starting with the example called as job sequencing with deadlines. As the name indicates, job sequencing with deadlines. We are here to sequence the job in such a way that it has to be accomplished within its deadlines. And let us say that each and every job is having a particular deadline. Got the point? And here, as the the screen says, like we are given a set of n jobs here associated with the job I is an integer deadline di which is greater than or equal to 0. Never ever a job will be having a value lesser than 0. Always the deadlines of the job. Deadlines in the sense accomplishment of the task. For example, as I told, a person P accomplishes the task, that is, he has been given 2 days of time to complete the task. If he does it in one, so that is what called as solution for that. And if a person accomplishes in 2 days, that is also okay. If he accomplishes it beyond 2 days, or anything that is greater than two is considered to be infeasible solution. So we have to understand very clearly what are optimal solutions, what are feasible solutions, what are infeasible solutions. So anyhow, when I'm going to explain with an example, the things will become very clear. Associated with job I, that means there may be n number of jobs, and associated with job I, let us say job I, that is the first job I are integers. So is an integer deadline, that is 1, 2, 3, 4 are the deadlines, and there are profits associated. Now, what do you understand by this profit? And it's been clearly mentioned that it should be greater than 0. What is the meaning of this profit here? Profit in the sense whenever you accomplish a task, something is earned. So what is that going to be earned is that is considered to be the profit. For example, accomplishing a person is being given a task. If he accomplishes within 2 days, say an incentive of say for example $10 is being going to be given to him in addition to his salary. That is what called as the profit here. Similarly, you can understand it onto the same line. When the jobs are being accomplished within the deadlines, then the profit is going to be earned. So this is, and here also it's been clearly mentioned that the profits are going to be greater than 0. They are not fractional profits. And now for any job I, the profit PI is earned if and only if the job is completed by its deadline, definitely. When the job is completed, then only the profit is going to be earned. Otherwise, no. So there is a double if there. To complete a job, one has to process the job in a machine, one unit at a time. As you see, I have written here on a machine. That is, there is only one machine. Got the point? There is only one machine, and there might be n number of jobs, and the machine will be given only for a one unit of time. There is only one machine, and the machine will be given only for one unit of time, and there might be n number of jobs, and these jobs might be having different deadlines. Please try to understand the scenario. There may be n number of jobs. The machine available is only one unit of time is going to be given to the jobs to be accomplished, and there might be different deadlines. Got the point? And one unit of time. So try to understand only one unit at a time. Now, some jobs, in spite of giving one unit of time, I gave you an example. The deadline for a particular job was 2. But if he has completed within 1 day, then it's very good. So this is what it says. The point here says the same thing, the last point. Now here the constraint, what we call it as every algorithm will be having some constraint associated with it. So also the problems also will be having the constraint here. So the major constraint or limitation or availability, what we call it as, only one machine is available for the job. You do not have, it means very clearly, if you have 10 jobs, it doesn't mean that you have 10 machines. Or if it doesn't mean that if you have 10 jobs, there might be 2 machines available. No, there is only one machine available. You may be having a number of jobs. Now, feasible solution, as I told you, is a subset of J jobs such that each job in the subset can be completed by its deadline. So this is what called as feasible. You know, I told you, two person A and person B. If person A is going to complete the job within half a day, if 1 day was a deadline given to him, if he does in half a day, and another person also completes the job within that 1 day, both are considered to be the feasible solution. But the optimal solution will be the job which was accomplished by person A, because he did the job in a small amount of time and a little amount of time, and he accomplished the task completely. So we call him to be more efficient. Here we call it to be the solution to be optimal. Now, value of a feasible solution J is the sum of the profits of the jobs. Now here, let me tell you, this particular problem, greedy method for job sequencing, is basically a subset problem. A subset problem in the sense, you can take the first, like you have subsets called as, you have 1, 2, 3. Now 1 is considered to be the subset 2. We have to generate all the subsets for this, 1, 2, and 3. So therefore, 1 is considered to be a subset, 2 is considered to be the subset, 3 also is considered to be the subset. Now even you can combine 1 and 2, 1 and 3, 2 and 3, and then so on and so forth. These are all called as a subset. So when you're combining 1 and 2 jobs, you know, when you accomplish it within the deadlines, definitely the profits will be earned. So therefore, when you accomplish job 1 and job 2, whatever the profits may be associated with it, that need to be added. Therefore, it says that summation of I belongs to JPI, that is jobs pertaining to the profits I. And optimal, as I told, is a feasible solution with maximum value. Here, the objective function is towards maximizing the value. Sometimes the objective functions will be for minimizing the value. This is a very good example for maximizing. We want to maximize the profit. In some examples, it might be minimizing that minimal use of machines, efficient utilization of the resources. This is a very good example which can be considered in an operating system. We want minimum resources of the operating systems to be utilized when a task is going to be accomplished. So this has got its example in operating system. So let us go on with an example. The things will become very clear. Yeah. So here, as you can see here, n is equal to 4 indicates that we have 4 jobs, and these jobs have got a profits of P1, P2, P3, and P4. P1 is associated with a profit called as 100. P2 is associated with a profit called as 10. P3 is associated with a profit called as 15. P4 with 27 respectively. What is the meaning of this one? It means that if the job 1 is going to be completed within a deadline, then a profit of 100 is going to be achieved. And what does P2 means? If a job 2 is going to be accomplished within the deadline, then profit 10 is going to be earned. So on and so forth for 15 and 27. Now, what are these D1, D2, D3, D4? As I told, these are the deadlines and these are integer in number. In the sense, I tell you as a whole, what does this problem indicate is we have 4 jobs, and the job 1, if it is going to be completed with a deadline of 2, a profit 100 is going to be earned. If job 2 is going to be accomplished within a deadline of 1 unit of time, then we are going to achieve or get an earned a profit of 10. Similarly, if job 3 is going to be done, and if it is going to be accomplished with a deadline of 2, then profit 15 is going to be earned. So on and so forth for 27 as well. That is a job 4. If it is going to be completed with 1 unit of deadline or 1 deadline, whatever may be the units, I'm just calling it as a unit. So a profit of 27 is going to be earned. Now, let us see all the feasible solutions here. You can see here we have table representing the feasible solutions, processing sequence, value, and description. Now, what does this mean? Feasible solutions are all the solutions which can be considered, which is not violating the constraints of deadline. That is going to be completed within that time itself. Let us say how. Now, feasible solution, that is, let us say we have written it in bracket indicating that this is job 1. Since it's a subset, people, this is subset problem. So therefore, we are going to consider 4. We can consider 4 are the number of elements. So the subset we can consider is 1, 2, 3, 4. Then you can consider 1, 2, 1, 3, 1, 4. Then 1, 2, 3. Then 2, 3, 4, etc. So let us start with the deadline, or sorry, start with the job 1. This is having a processing sequence as 1 itself, and the profit that is going to be earned is 100 here. Now, what do you understand? Since there is only one job, there is no sequence. If you would have 1 and 2 together, then we would have scheduled the sequence here. We just it's a one job, we are just keeping it as it is. And here the value, that is a profit of 100, is going to be achieved by, this is the description. So let us say the job has started at a time called as 0. The job has started at a time called as 0, and then it has accomplished, that is the job got over at 1. Now you can see, just see to the deadline here. This is a job 1. This job 1 is having a deadline of 2. This 2 is greater than that of 1. So therefore, this is considered to be the feasible solution. Always the deadline has to be lesser than or equal to other job. That is the 1 unit. That is 1 unit of time. So here, it was only one job, one machine was available, and that job could be very easily completed within 1 unit of time. And this one is far lesser than that of 2. So this is considered to be the feasible solution. Now coming to job 2 here, since again there is only one job we have considered here, so no processing sequence, we'll write down just 2 as it is. And it has got a profit of called as 10 here. And next one, you can see the next one, you can see that the job 2 has got a deadline of 1 year, and the machine available was only 1, and therefore it was available for 1 unit of time, and therefore the job 2 got accomplished here. Another one, job 3, you can see here, this is another one, and again we don't have a processing sequence here. This processing sequence over here is just 3, and the profit associated with it is 15. Therefore, we are going to write down 15 here. And now here you can see this job has got accomplished with a duration of within 1 unit of time. And the deadline of this job 3, you can see here, deadline of job 3 is 2, which is far greater than that of 1. Therefore, this is also considered as feasible. Therefore, I have written here feasible, and feasible solution. Similarly, job 4 also onto the same line. Now, when you compare, now here we are going to see the, we are generating the subsets here. So 1, 2, let us see whether whether 1, 2 when we have used, whether we are going to violate the constraint of deadline or whether it is possible. Now here first let us sort it out, because here you have 1 and 2. Now here I'm going to just, what you say is that I'm going to reorder. Our processing sequence has been changed here 2 and 1. Why have I done over here is that job 2 has got a deadline of 1. So therefore job 2 has been returned first, and job 1 has a deadline of 1. Therefore it has been returned later. And similarly, you can see here, why did we write it as 110 is, first the job 2 will be accomplished. So this job 2 is having a deadline of 1 and this is 1. Therefore, we are going to first take up the job 2 and then we are going to take up the job 1 because due to deadlines here, we are sorting it according to the deadline. Job 2 was having a deadline of 1, so we have returned it first, and job 1 was having a deadline of 2, so therefore we have returned it later, and job 2 was having a deadline. You can see here, job 2 is having a deadline of 1, therefore we have returned it first, and job 1 is having a deadline of 2, we have returned it as later. So here we have earned a profit of 110. How is this? The first job 1 is going to be accomplished. So 0 to 1. Therefore, one machine, job 2 was having a deadline of 1, it got accomplished. Then again, another, you see here, we have drawn, another job 1 was taken. And after, because we have only one machine, here this is a matter of point of to be considered here. After 1, we have only one machine. So therefore, after the job 2 gets over, we are going to schedule job 1 here. So job 1 is having a deadline of 2. So therefore, there is no problem at all. It is going to complete after job 2 gets over. So this is also going to be considered as a feasible solution. Hence, we have added 100 plus 10, 110 here. Again, let us consider 1 and 3. 1 and 3 are having both the same deadline. So it doesn't matter what the sequence is. Whether you take 1, whether you take 3, that doesn't matter. Now let us see how is this going to be done. Now 0 to 1, job 1 is going to be done. And then again, we have taken, for example, job 1 first. And job 1 is having a deadline of 2. So that doesn't matter. We are going to have, as I told in the previous slide, 1 unit of time is given for each of them. And since the deadline of it is 2 here, the 2 is greater than 1. So therefore, satisfactorily it can be completed. And after job 1 is getting over, we can start with job 3. And this is not at all a problem because job 3 also is having a deadline of something called as 2. So it is 2 is equal to 2, not a problem. Now again, 1 and 4, we are going to sequence it 4 and 1 because 4 is having, according to the deadline, I told you we have to sort it. So here you can see 4 is having a deadline of 1 and 1 is having a deadline of 2. So first we'll be writing 4 and then we are going to write down as 1. Similarly, so here you can see job 4 is going to be first accomplished. It is having a deadline of 1 and then job 2 because it is having, so 2 is greater than or equal to 2. Not a problem. This also can be completed. Now let us consider job that is 2, 3. So 2, 3, both 2 and 3, let us see what are the deadlines here. So as you can see here, 2 and 3 will be, I think 2 and 3. Yes. 2 and 3 are having a deadline of 1 and 2. So therefore, first 2 will be completed, first 2 will be written and then 3 will be written. You can see here 2 and 3. So first job 2 will be completed and then job 3 will be completed because each of them are having 1 unit of time. So when you add the what is called as job 2's and job 3's profit is just 10 plus 15, you are going to get 25 over here. Now next important thing is you have to consider very important thing. Now, when you're going to consider the subset called as 2 and 4, let us see what are their deadlines. Yeah. 2 is having a deadline of 1 and 4 is also having a deadline of 1. This is highly infeasible solution because you have got the deadlines as 1. The task need to be completed within 1 unit of time. But both are having the same deadline. Either you can perform job 2, which is already we are done, or you can do it job 4. But both of them cannot be done because the deadlines of them are same. Like for example, if you do job 2 first, this will be completed, but you cannot further go ahead and do job 4 because here you're getting the time called as 2, that is it is going to be completed within a time frame of 2 which is greater than the deadline of J4. That is job 4 has to be completed within a deadline of 1, as you can see here. Job 4 should be completed 1, but over here according to this diagram you can see here it is completing, therefore this is considered as an infeasible solution. Even 4 to also onto the same line. Now next we are going to go with 3 and 4. 3 and 4 we are sequencing it first 4 and then 3. Now why is that we are doing? Again we are 3 and 4. 3 is having a deadline of 2, 4 is having a deadline of 1. Therefore first 4 and then 3. This is what we have done here. And the total profit earned for this total added with profits 4 and 3 is 42. This is considered to be feasible solution because 4's deadline is 1, it is getting accomplished, and the job 3 is can be lined up after J4. So since it is 2 and its deadline is also 2, so this is considered to be a feasible solution. Now when you consider 1, 2, 3, again this is the subset 1, 2, 3. If you consider this, we are ordering it in 2, 1 and 3 because 2 is having a deadline of 1. 1 is, I think, 1 is having a deadline of 2. So we are doing it as 2, 1 and 3. Now let us say why is it called as an infeasible solution. Now you can do the job 1, it will job 2, it will be accomplished with a unit of 1. Even you can complete the job 1 because job 1 is having a deadline of 2. Yeah, job 1 is having a deadline of 2, even you can do that. But job 3 also should be completed. You can see here, job 3 is having a deadline of 2 here. But when you consider this, after accomplishment of job 2 and job 1, there is the third has to be lined up. When you line up this, it is going to complete at a point called as 3, which is greater than the deadline. So therefore, this also will be infeasible. Now we have considered everything amongst them, and we have seen that all these are feasible solution. Only the most appropriate answer is 1, 4, because the job 1 and 4 is giving the maximum profit here. I told you this is a particular example for maximizing the profit. So therefore, maximizing function we normally call it as, it is having a solution called as 127. So the optimal solution is the subset 1, 4 and the profit gained is 127. Hope this particular example for greedy methods for job scheduling, job sequencing is the more understandable to you with the help of this type of time frames which I have drawn. So I'll come up with more videos on next on knapsack problem using greedy method. Thank you all. Thank you.